So let's start from where we left off. We have copied the constants and the variables to the program. We've cleaned up how we talk to the users to get their input. We don't have any calculations, and then we clean up the output the way we wanted to. Let's run the program again just so you remember how it looks like. Let's try some data, just in case you are not watching the two videos back to back. So 40.75, 100.25. So it looks right. That's where we were. So now let's think about how to calculate. So I'm going to use the if-else statement to demonstrate how to do it. Actually, there is, of course, many ways to do this. There's actually another way that may be more efficient in my opinion. So I was thinking to give you some bonus extra credits if you figure out a different way to calculate this. But the way I'm doing it right now is using an if-else statement. If the number of hours worked is less than or equal to 40 hours, I'm just going to calculate the gross pay equals to hours worked times pay rate. But if there's overtime, then we will calculate the overtime pay, which is equal to the hours worked minus 40 times pay rate times the overtime rate. Regular pay is equal to 40 times pay rate, right? And the total will be equals to regular pay plus the overtime pay. I would like to copy and paste this to my program. One good way to do this is because this, you see, is in a box. So I would just do Control A and then Control C, or Command A, Command C in Mac to copy. Go back to the program. I will just copy and paste here. And you see, because it's not indent, I can highlight it and tap, and everything will indent to one level down. So now I know how much gross pay is. I still need to calculate the taxes. Taxes is equal to gross pay times, if we don't remember the constant's name, we can double click, copy, paste, semicolon to end it. Net pay equals to gross pay minus taxes. So this should give us good result, but we need to test our program. Testing is actually very important. So let's enter some numbers that we've used before. Let's try the 60 hours, and then I believe that is $100 per hour. But it's not correct. Why? Because the tax rate we said we were going to use 20%, which is 0.2. So let's run it again. 60, 100. Now it's correct. $7,000, taxes $1,400, $5,600. Let's also try the other example. Usually you really do want to test it in different set of data. This time we use the example that we were doing in the PowerPoint, 30 hours, $200 per hour, and there's no overtime So it's exactly like what we calculated. But actually, we didn't really comprehensively test the program. We always use integers so far. We haven't really used the um, uh, double, really, the numbers with decimal points. So let's try it now and see what happens. Let's use 40.75 and then 100.25 per hour. And you see it, it, it comes out nice, the output, and we should definitely use a calculator to check our numbers, but I'm not going to make you wait. And I can tell you this is correct. So, but what I want to change is that you see there's like 0.278. That's not what a, the dollar, the money will be represented. And so I want to format it so that it can give me the, in this case, it should be 412.28, for example. So let's go back to the slides. So let's look at how we can format the output to exactly 2 decimal points. And I will tell you that this is the code that can make it happen. The IO manipulator is the library that we will, or the directive that we will need to use the keyword fixed and the this function called set precisions. We'll actually explain more about functions later. So let's go to this link first. This is a documentation, so I kind of want you to take a look because eventually you will find it very useful. So the directive is called IO manipulator, and you can see what kind of parameter, basically keywords or functions that you can use if you make this directive available. And the one that we are using is set precision. If you click on it, you can see the explanation of how to use it or what it does, and also an example. And I always like to look at examples because sometimes it's really easier to understand than reading the description sometimes. You can see, even though for the same number f, it will give you, if set precision 5, it will actually give you 3.1416. But if you use the word fixed or the keyword fixed in front, you would actually get 5 digits. This is the third one is the output right afterwards. So, and also you can observe that there the std : why is needed this way is because we didn't set the namespace in this example. That's why we use the namespace, so that we don't have to put stat : in every single like before the cout and the cin and so on. So let's go back and copy our code and put it in our program. So it's the output that we want to, we'll put it here first, and then, so to cut something, Control X or Command X in Mac, and then I already put it there earlier. So we would, now this line of code is basically going to replace the first line of code. The fix needs to be there, so we tab and indent it a little bit. We get rid of this line, and then we just going to copy and paste. I actually want to show you without the fix what will happen. So let's run it first. Let's see what happens. There's some error, which is nice. I can show you what error. So it complains about this line. I think I think it's because of the interesting. I think it's because of the formatting of the PowerPoint. So it gave me an error because the double quote is not what they expected. So now let's use the same set of numbers, 40.75 and then 100.25. You see, it's not working because the fixed is not there. So I copy this, so now I can paste it, and let's try again. Exactly the same number, and now you see that the dollar is displayed as expected with only 2 and exactly 2 decimal points. Play with it. Maybe I will test you, or in the exam I will test you what will happen if you do this and or set the precision to other numbers. So play with it. This is for fun.